Have you ever been in a group, maybe making a decision, and somehow the group just lands on the right answer, even if no single person was totally sure?
Yeah, it's like a kind of collective intuition sometimes. There's actually a fascinating mathematical idea that tries to explain that.
Right, and that's what we're diving into today. Condorcet's jury theorem sounds be a bit academic, but it comes from this 18th century French philosopher and mathematician, Marquis de Condorcet.
Absolutely. Condorcet was a major Enlightenment figure, and this theorem, well, it really probes why group decisions can sometimes be surprisingly accurate. It's about pooling judgments.
Exactly. So for this deep dive, we've got sources explaining the theorem itself, plus analyses of Condorcet's wider work, specifically his selected writings, edited by Keith Michael Baker.
Right, Baker's collection is key for context.
Our mission is basically to get the core idea, understand the assumptions behind it, where it falls short in the real world, and, why it's still relevant. We want those aha moments without drowning in math.
Think of it as a quick way to grasp a really influential theory. And Baker's work shows us Condorcet was thinking about so much more than just this theorem.
Okay, let's jump in. What's the absolute core idea of Condorcet's jury theorem?
So the main point is this. Imagine you have a group of people making a decision. If each person, individually, has a better than 50% chance of being right.
Okay, so they're better than just flipping a coin.
Exactly. If that condition holds, then the majority vote of the group is even more likely to be correct than any single individual.
Ah, I see.
And this is the kicker: the bigger the group gets, the higher the probability that the majority decision is the right one. It gets closer and closer to certainty.
Wow, okay. So more people, better odds, assuming they're individually, slightly knowledgeable. That sounds like a powerful argument for democracy or juries.
It really is. The theorem provides a kind of theoretical justification for why majority rule can work well in systems like voting, jury trials, even expert panels. It suggests group wisdom can emerge under the right conditions.
Okay, you said under the right conditions. That sounds important. What are those conditions? What assumptions does the theorem make?
Good question. Our source on the theorem explanation lays out 4 key ones. First, it assumes a binary choice, meaning the decision is between just 2 options: guilty or not guilty, true or false, candidate A or candidate B, simple yes, no.
Okay, like a courtroom verdict. Makes sense. What's next?
Second, independence of judgments. This is a big one. It assumes each person makes their decision without being influenced by anyone else in the group.
Okay. No peer pressure, no groupthink, no one dominating the conversation.
Right. Everyone forms their opinion completely independently.
That already sounds challenging in real life, doesn't it? People naturally influence each other.
That's a major criticism. We'll definitely come back to that. The third assumption is homogeneous competence.
Meaning everyone's equally good at making the right choice.
Pretty much. It assumes every individual has the same probability, let's call it P, of being correct. And crucially, that P is greater than 0.5, better than random chance.
So everyone's equally skilled, and they're all at least slightly better than guessing. What if you have experts mixed with novices?
Then the basic theorem doesn't quite fit. If some people are actually worse than random PP 0.5, they can drag the group accuracy down. So, yeah, equal competence above 50% is assumed.
Okay, and the last assumption.
Simple. Majority rule. The group's final decision is whatever option gets more than half the votes.
Got it. Binary choice, independent thinking, everyone equally decent at it, and majority wins. So how does the math actually show the group gets smarter?
Well, the explanation source mentions it uses probability theory, specifically the binomial distribution, without getting lost in the weeds.
Please, yeah. Keep it high level.
Okay. Imagine you have n people, each with that p chance of being right. The math lets you calculate the probability of getting exactly k people right out of n.
Okay.
To find the probability of the majority being right, you just add up the probabilities for all the scenarios where the number of correct people is enough to form a majority. So more than half the group.
Right, you sum the chances of all the winning outcomes.
Yeah.
And the big result is?
The key mathematical finding is, as n, the group size, increases, the probability of the majority being correct rockets towards 100%, provided the individual probability p is greater than 0.5.
Wow.
But there's a flip side. If individuals are more likely to be wrong, p.5, then as the group gets bigger, the probability of the majority being wrong also approaches 100%.
That's fascinating. So big groups amplify competence, but they also amplify incompetence. If people are generally clueless or misinformed, a larger group just becomes more confidently wrong.
Exactly. The average competence is absolutely critical. Our source gives a neat example. Just 3 jurors, each 70% likely to be right, so p equals 0.7. The probability of the majority being right isn't 70%, it jumps to over 78%.
So even with just 3 people, you see a noticeable boost. Okay, the theory is elegant. But we already touched on independence being tricky. What are the other big real-world limitations or criticisms?
Yeah, the source discussing the theorem highlights these. We mentioned independence. People talk, share info, get swayed. How do you see that playing out, say, on a real jury?
Well, you might have one really persuasive person. Maybe they speak first or loudest. And they could pull others along, even if their own reasoning isn't the most sound. The group decision might reflect that influence,
Yeah.
not just the sum of independent judgment.
Precisely, and that undermines the whole mathematical basis. Then there's non-homogeneous competence. We talked about this. People aren't equally informed or skilled in reality.
Right. So if you have a few genuine experts, but lots of people who are just guessing, the guessing votes could potentially outweigh the expert votes under simple majority rule.
Exactly. The theorem's neat prediction relies on that level playing field of competence, which is, rare.
Makes sense. What else?
Another point is that many decisions aren't binary choices. What if you're choosing between 5 different policy options or ranking candidates?
Yeah, the real world is often shades of gray, not just black and white. The basic theorem doesn't seem built for that kind of complexity. You'd need something more sophisticated.
Correct. And finally, think about the quality of information. What if everyone in the group is working from the same bad data or misleading news report?
Oof. Then the majority agreeing just means they've all reached the same wrong conclusion based on faulty premises. It's groupthink based on bad info. Collective error.
That's a huge risk. So these assumptions, independence, competence, binary choice, are serious hurdles in practice.
Definitely. But despite all that, you said the theorem still has relevance. Where do we see its ideas applied, or at least reflected?
Well, the theorem explanation mentions several areas. Democracy and voting is the obvious one. It gives a reason to believe that, if voters are on average slightly better than random at picking the better candidate or policy.
Then a large electorate using majority rule has a decent shot at making a good choice.
Kind of, yeah. It suggests why democracy can work, theoretically. It also points to the importance of things like education and access to diverse information to boost that average voter competence.
Okay. And jury systems, obviously. The name kind of gives it away.
Right. The ideal is that independent jurors weighing evidence will, as a group deciding by majority, be more likely to reach the correct verdict. Though, again, all those caveats about influence and competence apply.
It also sounds a lot like the idea of crowd wisdom. Asking a huge crowd to guess the number of jelly beans in a jar, and the average guess is weirdly accurate.
Exactly. It taps into the same principle. Aggregating many independent, imperfect judgments can cancel out individual errors and arrive at a surprisingly good collective answer. Think prediction markets, or even something like Wikipedia, in a way.
That's a cool connection. And you mentioned machine learning, ensemble methods.
Yeah, it's a neat parallel. In machine learning, an ensemble method combines predictions from many simple algorithms, weak learners. Each might only be slightly better than random.
Like the individuals in Condorcet's theorem.
Precisely. But by combining them, often through some form of voting, you can create a much stronger, more accurate overall model. It's the same core logic. Aggregating weak signals creates a strong one.
Fascinating. Okay, so the theorem itself has these tendrils reaching into lots of areas. Let's zoom out now to Condorcet the man. Who was he beyond this theorem?
This is where those sources on Baker's selected writings come in. Marquis de Condorcet was, well, a powerhouse of the French Enlightenment. A mathematician, yes, but also a political theorist, a writer, a social reformer, even involved in the Revolution.
A real Renaissance man of the Enlightenment. And Keith Michael Baker's collection from the 70s is the key English source.
It seems to be. The analyses we looked at stress how Baker's work made Condorcet's incredibly diverse thought accessible. It covers his philosophy, politics, social science ideas, history, including bits from his famous sketch for a historical picture of the progress of the human mind.
Ah, the sketch of progress. What was that about, fundamentally?
It's his grand vision of history as, essentially, humanity's inevitable march towards reason, perfection, and happiness, driven by knowledge and enlightenment. Very optimistic.
Sounds very Enlightenment. And Baker's edition brought texts to English readers that they couldn't easily access before.
Yes, apparently it included new translations of important works. It really opened up his thinking. And Condorcet's own intellectual path was interesting from pure math towards applying mathematical and empirical thinking to social problems.
Like trying to create a social mathematics.
Sort of, yeah. He's seen as a forerunner of modern social science, trying to bring scientific rigor to understanding society and driving reform.
And his view on revolution, was it just about swapping rulers?
No, according to the analysis, he saw true revolution as a deeper transformation aimed at establishing liberty and rights for all, not just a change in power. He was deeply invested in the ideals of the French Revolution, at least initially.
Interesting. And he had connections to the U.S. Franklin, Jefferson.
Yeah, he corresponded with them, admired the American experiment, saw it as putting Enlightenment ideals into practice. A kind of transatlantic conversation was happening.
And Baker's edition apparently includes both French and English. That's useful for scholars.
That definitely helps capture the nuance. And importantly, the sources highlight that Condorcet wasn't just an abstract theorist. He was a passionate advocate for concrete reforms, abolishing slavery, women's rights remarkably ahead of his time on that, and major public education reform. These causes show up in the writings Baker selected.
So the jury theorem fits into this much bigger picture of using reason and analysis to understand and improve the human condition.
Exactly. It wasn't just a math puzzle. And, while the basic theorem has limitations, researchers haven't just left it there. Our source mentions extensions.
Huh. Like what?
Models that try to account for differing levels of competence, or use weighted voting where maybe expert opinions count more, or handle decisions with more than two options. The core idea has been built upon.
So it's been adapted to be maybe a bit more realistic.
People try. But the enduring value of the original theorem, even with its simple assumptions, is how clearly it shows the potential of majority decisions under those ideal conditions. It gives us a baseline, a theoretical benchmark.
And a strong reminder to think critically about whether those conditions, especially independence and competence, actually apply when we see groups making decisions.
Absolutely. And stepping back, Condorcet's overall legacy, which Baker's collection helps illuminate, is just immense. He laid groundwork for social science, championed democratic ideals, and applied mathematical thinking to social issues in pioneering ways.
Okay, so wrapping up this deep dive, the big takeaway seems to be Condorcet's jury theorem gives us this powerful, if idealized, mathematical reason why groups can be smarter than individuals.
If individuals are reasonably competent and think independently, it shows the potential of majority rule to aggregate wisdom, but also flags the crucial importance of those assumptions.
It really makes you think about group decisions you're part of, right? When does it work like the theorem predicts? And when do things like social influence or unequal knowledge mess it up?
Totally. And if you want to go deeper, Condorcet's own writings, perhaps via Baker's collection, offer a much broader view of his Enlightenment vision.
Definitely food for thought. And maybe here's a final question to chew on. In today's world, so connected, so full of potential echo chambers and instant information or misinformation, how do we actually foster that independence of thought that Condorcet's theorem relies on? How do we get the benefits without falling into the traps?
That's the million-dollar question, isn't it? Something to ponder.
Indeed. Well, that's all the time we have for this deep dive. Thanks for exploring Condorcet with us.